Alright, so today I'm going to talk about simplifying radicals. Just a quick review. I'll show you 5 examples starting with this one up here. So let's get into it. One thing you want to remember when you're adding radicals, different than multiplying radicals, alright, the square root of a plus the square root of b is not equal to the square root of a plus b, right? These two expressions are not equal, so when you go to simplify something like this, you can't just add the 125 and the 45 together. So instead what we do is we look for factors of 25 or 125 that are perfect squares, because I'm dealing with 2 square roots here. Factors of 45 that are perfect squares. So just a quick review. 25 times 5 equals 125. The reason I chose the 25 is because it's a perfect square. On the right hand side term, I could say 45 is the same thing as 9 times 5. Doing this because 9 is a perfect square. So let's break this apart. Okay, these are not being added, so these can be broken apart. When I have the square root of a times b, make these a little bit better, that does indeed equal the square root of a times the square root of b. So let's just keep these in mind. So over here I could say, well, this is the square root of 25 times the square root of 5 plus the square root of 9 times the square root of 5. Okay, so we know the square root of 25 is 5, so go ahead, write that in. 25 times the square root of 5, plus we also know that square root of 9 is 3. And that's still being multiplied by the square root of 5. So you could look at these as like terms, root 5 and root 5, 5 of them here and 3 of them here, makes 8 of them. But what we're technically doing is factoring out the root 5. So I'll step it all the way out. So 5 plus 3, and we're multiplying that by the square root of 5. So this is, if I distributed this back out, I go back to where I started. So that's why a lot of times once you get good at this, you'll just go from here to here. So that's the first example. Let me know in the comments down below if you have any other questions about this one before we go on to example number 2. Example number 2 here, this is a similar example, except that notice now we have cube roots, not square roots. So where before we were looking for factors of the radicand that were perfect squares, now we're going to look for perfect cubes. So let's see. I can rewrite 57 as 27 times 2. Now there's other factors like 9 times 6, say, but neither one of those is a perfect cube. So that's why I use 27 and 2. And perfect cube that's a factor of 16 is 8. So 8 times 2 is 16. So here's what we'll do. We'll break this up again using this property here. So cube root of 27 times the cube root of 2 plus the cube root of 8 times the cube root of 2. So now I have a perfect cube right here. That becomes 3 times the cube root of 2 plus, let's see, this becomes 2. 2 times the cube root of 2. And same, a lot of times these lend themselves to this, but I have like terms, or I could factor out the cube root of 2. So leaving me with 3 plus 2, which is 5. Let's get that written in there. So 5 times the cube root of 2 is as far as this one will go. So that's example number 2. All right, so here's the third example. Sometimes you'll have a binomial expression in the radicand. So what I do notice is I see a 36 there, which makes me think of square root of 36, which would be 6. So I'm going to start by factoring that 36 out of that binomial expression. So now I can use this property here to break this up and say, well, that is the square root of 36 times the square root of x squared plus y squared. So keep in mind, this is not true. I cannot say that this is square root of x squared plus the square root of y squared. That does not work because that's a plus sign. But I can simplify the square root of 36 as a 6. So 6 times the square root of x squared plus y squared, and that's how it simplifies. Okay, so for our fourth example, we have another binomial in the radicand, and it's 27a cubed plus 63a squared. So again, it's a square root this time, so I'm going to be looking for factors of these two terms that are perfect squares. So how about we try, let's see, 9. I'm going to factor out of that expression, a cubed and a squared, so I could factor out an a squared. So when I factor out the 9 from 27, I'm left with a 3, and a squared times a is a cubed. Then plus here gets a plus here. When I factored the 9 from 63, I have 7 remaining, and a squared comes out, so there's no a factor left inside. So now I use this property, and I'm going to break this up. This becomes the square root of 9a squared times the square root of, make my lines a little darker, 3a plus 7. So the square root of 9 is 3. The square root of a squared is just a. So we would leave this as 9a times the square root of 3a plus 7. So make that stop right about there. Okay, so let me show you one more example after this one, and it's a little bit trickier. So fasten your seatbelt. All right, here is our fifth example. I switched colors because the other color wasn't working so good. So in any event, I'm adding two different radicals here. So remember, I can't add these together and put these two terms inside the radicand. But what I can do is rewrite. So I could say the cube root of x to the fourth is the cube root of x cubed times the cube root of x. Because I didn't change the index is still 3, and x cubed times x is x to the fourth. Plus, over here, I'd have the, well, I can separate this too. Cube root of 8 times the cube root of x. So here's what happens. The cube root of a number cubed is just the number times the cube root of x. That doesn't go any further. So it's just cube root of x. Plus, cube root of 8 is 2. So that works out pretty nicely. And that's times the cube root of x. So we're almost done here. This is tricky on these. If I factored out the cube root of x, I'm going to have an x plus 2 left over. So I'll factor out this way. Cube root of x, and then I have times, this one's not working good either, x plus 2. So, the cube root of x times x plus 2 would be the final answer. You might see it written this way, x plus 2 times the cube root of x. So either way you might see this. That's visible. So either way you might see this, but this is the final answer, how to answer this question. And hopefully you've got some value out of these. If so, I'd invite you to like and possibly subscribe. Also comment and share this content with people who you think might be who might benefit from it. In any event, I'll see you the next time. Mr. Nolde, signing out.